Hi, my name is Manuel Guadalupe Macias, and I'm going to present this poster of the International Material Research Congress of 2022. This investigation, this called investigation of the psychical properties of lead-free composite system of this material adopting with this. My director of the thesis is Suba Sharma, with collaboration with Gabriel Rojas, Vargas Viveiros, and Jesus Siqueiros Beltrones, and at the end, Oscar Raymond Herrera. The lead free system of this compound, named as BLPEFO and BFN, with percentage of doping of 0%, 4%, 8%, and 12%, were synthesized by conventional solid state route, and the structural, microstructural, the electric property were studied by XRD analysis that reveal there is a significant change in structural parameters with BFN substitution, and the microstructural analysis done by scanning electron microscopy, room temperature UV visible spectroscopy were performed to get the bandgap energy for all samples. The objectives of this work is synthesize the powder using the solid state reaction for this compound from the precursors that we use. And the second one is to make the pressing of the powder to form the ceramic pellets with the correct size to be able to carry out of the characterization. And at the end is evaluate the ferroelectric, the electric properties, and observe grain size using different electrical and structural methods. For the experimentation, uh, we use the precursors of oxide, lanthanum oxide, iron oxide, niobium oxide, bismuth oxide, and praseodymium oxide. This going to go to solid state reaction, and after that we calcinate the powder, and after the calcination we add polyvinyl alcohol 1 drop per gram and do the pressing, and after desintegrates this pellet, and at the end we obtain this pellet. The characterization for the pellets that we use is XRD diffraction and ferroelectric measurements, the electric measurements, SEN and EDS. As we can observe, this is the equipment for the ferroelectric and this is the equipment for the electric measurements. In the images of the SEN, we can observe at the principle the 0%, 4%, 8%, and 12%. We can see this grain is different from the 4 and 8. This is for the doping. The grain is decreased. This image is for 5000x and this is for 10,000x, and it's the same for all of the composition. And after that we do the analysis of the XRD diffraction. The patterns we observe is for information from the iron oxide, niobium oxide, lanthanum oxide, praseodymium oxide, barium carbonate, and bismuth oxide to the left, to the right. And after we do the characterization of the electric measurements using the ferroelectric equipment and obtain these hysteresis loops. And as we can see, the behavior of the ferroelectric of these materials is not very good, and we can conclude this is paraelectric material. And after that, we do the electric measurements, and we can observe at the room temperature we have a good dielectric constant at low frequencies, and is equal for the all of the composition. And after that, at higher temperatures, we lose in the electric constant. And at the end, we do the compositional analysis by energy dispersive X-ray spectroscopy by EDS, and we can observe the percentages of all of the compounds present in this material. We can conclude in the area of the electronic and computing. The aim is to make devices smaller and more efficient in this area, being able to understand, study, and apply the properties of the multiferroic material, give us a guide for the creation of multifunctional materials. The results show a correct synthesis by the solid state reaction method, which was confirmed by different structural characterization such as XRD and electrical, how the ferroelectric and ferroelectric, when measured the dielectric constant, which show good behavior around temperature, decreasing at higher temperature. These studies give the possibility to better understand this type of material as open a window of opportunity to apply in new generation devices. And thanks for watching, and I'll leave that.